Okay, so chapter 1, section 1. Section 1 is statistical and critical thinking. And we begin with a key concept. The process involved in conducting a statistical study consists of prepare, analyze, and conclude. Statistical thinking involves critical thinking and the ability to make sense of results. Statistical thinking demands so much more than the ability to execute complicated calculations. And this is a good thing to emphasize. In particular, in this class, by the way we formatted things, we are going to de-emphasize complicated calculations. There are plenty of complicated formulas that you will see presented in slides and in the textbook. But we are going to lean on StatCrunch or other things that people might use to handle all of those complicated calculations for us so that we can instead focus on the concepts. And then we will gain the use and skill of those tools, but we won't focus a lot on the formulas that they're using to do their work. We'll focus on why we're using that formula and what the result means so that we can use it at the right time and talk about the results. So let's just pause the slides here for a second to get the big picture in mind as we will then start to look at some definitions. So what is the big picture of statistics? What is the big idea? The big idea is that you want to investigate some aspect of a large group. So a simple example would be, I want to investigate something about all of the students at DVC. And that's a large group, some thousands and thousands of students at DVC. So the idea behind statistics is the way I can investigate some aspect of them when it's challenging because it's such a large group is that I investigate that aspect in some smaller portion of that group called a sample. And then I try to use the results that I see from my investigation of the sample to then draw conclusions about the entire population. So a simple example to wrap your mind around this idea is, let's say I was curious for some reason, maybe I'm going to produce some clothing, or maybe I need to build some structures on DVC with doorways. I'm curious on average how tall students at DVC are. Well, one way that I could try to figure that out is I could go to every student at DVC and ask them how tall they are. Or even more accurately, since some people don't know exactly how tall they are, maybe I could actually ask to measure every student at DVC and how tall they are. Well, as you can imagine, that would be a large undertaking. It might be expensive if I'm paying people and I'm setting up a facility and I'm paying people to measure and I have to communicate with all the thousands of students at DVC. So to do that for the entire population could be a very challenging endeavor. But to do that for a sample of people would be a lot easier, a lot less expensive. The question is, how valuable is that if I only talk to maybe 100 people? How valuable is that sample of 100 people's information when trying to draw conclusions about the thousands of all the students at DVC? So maybe I would take a sample of 100 people and I would invite them all on a particular day. And for a couple of hours, I myself would very carefully measure how tall they are so I have accurate information. And then I would look at the results that I got. And I would say, well, from my sample of 100 people, the average height of those DVC students was 5'8". Now, does that mean the average height of all the students at DVC is 5'8"? Obviously not. In fact, I wouldn't even expect that would be the case because I just happened to take a sample of 100 people. And it's just by random chance likely that the 100 people I got don't happen to have the exact same average height as all the students at DVC. Here is where statistics and critical thinking for statistics comes into play. And so we will begin now down the road of thinking about that kind of a goal and that kind of a venture of taking a sample and talk about what kind of information I collect. We will give a lot of new vocabulary words about collecting that information, what kind of information it was, things like that. We'll begin discussing that today. And then slowly we will develop over the course of the semester how to look at the data that we got. That's the information. I'm already using statistical words. Data is the information we collected. How to look at the information we collected, maybe how to display it in some sort of a graph, and how to do some analysis on that information to help us draw conclusions about the population as a whole. So that's our big goal. That's the number one key concept for the whole semester, and it's summarized with this idea. The process involved in conducting a statistical study consists of preparing, meaning setting up to get a sample and thinking about how to do that. Analyze, meaning look at the results that we got from the small collection of the population that we collected, and then drawing conclusions about what that means, not just about the people that we're looking at, but out of the entire group that we want to consider. So having said that, are there any questions before I move forward and start to look at vocabulary about this idea, about this big concept? Let's see if I can pull up my chat box. All right, how about this? Is anyone willing to offer up, just as a concept, an example of a large group and what you might want to know about them that you might try to investigate with a statistical study? So you're just making it up, some big group, and some aspect of that group, like how tall they are, was what the aspect was in my example, that you might sort of imagine, well, I couldn't figure that out for everybody, so maybe I would use a statistical study to try to do that. Can anybody offer up an example? Either unmute yourself and chime in or type it into chat in any way, shape, or form.
Could it be like when they're trying to test food, like whether they like it or not?
Absolutely, that's a great example. So for the like it or not, a lot of times a company will plan on making a food product, but they don't want to set aside a whole part of their factory and spend millions of dollars and collect all this food and make a whole bunch of it and put it out for sale and find out the hard way that nobody likes it. So one of the ways that statistical study can be done is to try to determine if a big population would like something by running a sample test and having them test it and then looking at the results and then trying to then analyze those results and draw conclusions about whether enough of the big population would like it, so it's worth it for them to go onto this product and make a bunch of them and sell it. So that's a great example of how it's used regularly by businesses to investigate the value of making a product and whether they think it would be a successful product to launch. Anybody else want to chime in with an example, question, or comment about this? So as we go through these vocabulary words in particular, as we start to talk about the language of statistics, your brain will only really start to adopt this new vocabulary if you try to use it. New words can be read and understood, but if they're not used, they will be quickly forgotten and no longer usable. And so I encourage you all, as we look at these new words, to try to be as active as you can, even if that doesn't mean you're chiming in for the whole class, but try to imagine how you would use these words in a sentence, what examples of these words are for you, so that your brain starts to understand the definition and that this vocabulary becomes vocabulary that you can work with. In particular, even if you never really talk to people much about statistics, just to read in the future, the things we're going to read through the semester, these words need to be working words in your mind so that when the book and the videos use them, you know what they're talking about. And the only way to do that is for your brain to begin using the words as soon as you're learning about them. So let's move forward. Word number one, which I already used a little inadvertently too quickly, data. So data is the bread and butter of statistics. It's what you work with. So the description for data is collections of observations, such as measurements, genders, or survey responses. So in the example that I provided, when I had my 100 students and I measured how tall each of them was, I would record that. I would record that observation. And at the end, I would have 100 measurements of height, 100 examples of observed heights of DVC students. And that collection of those numbers, 5'2", 6'1", 5'7", or however I measured it, the collection of those results is data. In the example given earlier, where I had a bunch of people come in and tell me if they like some food that I was testing, it would be depending, the data would look like sort of what question I asked them. So if I said, do you like this, yes or no, then my data would be a bunch of yeses and nos. If I asked them something more elaborate to get a more detailed idea, like if you were to rate how much you like this as a number from 1 to 10, whereas 1 is it's detestable and I want to spit it out, and 2 is it's the most fantastic, 10 is the most fantastic food I've ever had in my life, and I asked people to rank it, well, then I would have a bunch of numbers from 1 to 10, a bunch of 3s and 4s and 5s. So data is the results that we got from our observations, from our study, from our sample. But you also want to immediately begin envisioning what that collection of those data would look like. It would basically look like a big list of numbers, or a big list of yeses and nos, or something like that. It could be a list of colors, like if my question was, what's your favorite color? Then my answers would be color. Or it could be, what's your favorite color of food? Like maybe you're thinking you're going to add some food coloring and you want people to like the color. So it could be a list of orange, blue, green, brown, black, of colors that people have provided as their responses. These are all examples of data. Okay, so try to imagine a situation like we talked about previously, where there's some population and you want to know something about them, in which you would collect data, as we've just discussed. Can anyone provide an example of a situation where they would collect data and what the data would look like that they had at the end after having done that? You can just try to make it up in your mind. If you're willing to offer it up to the class, that's great. Even if you don't want to go that far, I at least invite you to try to imagine envisioning that. Use your imagination so that the word data starts to mean something real to you. And if you're willing to share an example, that would be great too. Anyone want to share an example in chat or by speaking up of an example where they would collect data and what it would look like?
I think, YouTube and social media platforms collect data on their users to find out what type of stuff they like to watch and like recommend stuff based on that. So maybe they like collect data on how many, how likely you are to click on a certain video on a certain day or like something like that.
That's great. So you are opening up a fantastically large conversation, and your brain is now starting to think about the idea of using statistics, which is perfect. So let me help with the upcoming vocabulary and focus on the idea of data. They would not collect data on the likelihood of something happening. That is a probability, and that is a calculation that would be done on data that they had collected. So the data might be a list of times that somebody watching on this video clicked on a link to this other video. So it would be basically like maybe, of course, in their case, hundreds of thousands or millions of instances where this video being watched led to that one being clicked on. But then a calculation of that data might be, well, we saw when we added it up that 60% of the people watching this video clicked on that, that's a calculation. They had to calculate the 60%, and then maybe they could then say there's a 60% likelihood that someone watching this will click on this other one. So that's the difference between data collected and an analysis and a calculation on that data that allows you to draw a conclusion. That's kind of the whole thing in a nutshell with what you just thought of there. So Zach, that's a great example. The data itself, to focus on the data part, might be just a list of yes or no's. Did they click on that link when watching the video? So the group that they're looking at are people watching a particular video where there's a link embedded. And the data they're collecting is just yes or no's. Did they click on that link when they were watching the video at some point? And then the analysis might be, well, what percentage of them clicked on it so that we can make a probability argument. I know that's a lot, but that just shows us the road we're going down. And don't be afraid to start to imagine how data is used and what the goal might be, as well as focusing on what the data in that process would look like and how it would be collected. Let's go ahead and move forward. Lots to discuss. All right, so now let's say data is a collection of observations. So statistics is the science of planning studies and experiments, of obtaining data, organizing and summarizing that data so that you can present it and analyze it, and then interpreting those data results so that you can draw conclusions based on them. And so this is a nice overall picture of statistics. You can see that in general, this is the big word. This is the purpose of the whole semester. There's lots involved here. But even in that discussion about YouTube videos and the likelihood of maybe clicking through and watching something else, highlights all aspects of the statistical description given here. So there's a lot here. There's too much to go into detail here. That's basically the purpose of the semester. So let's keep moving forward. So first big word that I've already been using a few times, population. So what does this mean in terms of specifically talking about statistics? So for example, I talked about the population of all students at DVC and how I was curious how tall they were or something like that. But let's look at this definition, because the general word of the population is a little bit different than the specific word in statistics. The complete collection of all measurements or data that are being considered. End of sentence. Then it says, typically a population is the complete collection of data that we would like to make inferences about. So notice that it's already talking about the measurements that are being collected or that are being considered. So when I started my description, I said, I'm thinking about the population of all students at DVC. But students at DVC are not measurements. So that use of the word population is not the statistical use of that word. But then I said, I'm really curious about how tall they are on average. So the population I'm immediately then talking about in a statistical sense is the measurements of how tall all students at DVC are. That would be a population. Notice that would be a collection of height measurements, but for the entire group of all students at DVC. The complete collection of all heights as a data set, as a collection of data values, would be the population. Questions, comments, discussions about that? Question in the comment, it says, would a correlation study be used in statistics? Like an example, TV watching, violent behavior, or depression, gender, collection data, is it something to do with it? Yes, and we will talk about correlation in statistics. That'll be one of our subjects, and we will do analysis about correlation. So if you're curious about that, that's great, and you were gonna get some satisfaction for your curiosity this semester. All right, let me give you another example of population in this statistical use of the word. So a measurement that we could take about everyone in the country would be, did they have COVID or not? Did they at some point acquire the COVID-19 pandemic virus? And so for everyone in the country, the data value associated with did you get COVID or not would be yes or no. So I would be talking about a yes or no value for everyone in the country. That would be a population. It would be 350 million yes or no's. That would be a population. 350 yes or no's, where the yes or no answer is an answer to the question, did you get COVID? Now, I could do some analysis on that. I could, for example, add up how many yeses there were, add up exactly how many yeses and no's I have, and divide all my yeses by how many yeses or no's there were, and I would get a decimal that I could convert to a percentage, and then maybe I could draw a conclusion like 10% of the US population has had COVID. That would be a conclusion on the population data that I could make. But the data would be the 350 million yes or no's that I have to look at. Questions, comments, discussions about that? So in the book, as we move forward, it will be easy to conflate the idea of a population being the large group that you're going to collect a measurement from and the actual large group of measurements that you get. And so there's not a big distinction there, but technically speaking, population refers to the measurements. So if you happen to have a question in your homework and it gave you a list of possible meanings for population, you want the one that refers to the measurements of data being considered for the entire group. All right, moving on. Again, feel free to interrupt if you have a question at some point. Even if I don't ask for them, you can always just chime in vocally and just say, hey, Mr. Willett, I got a question. And that's very welcome. Okay, so now we have two more vocabulary words being given. We have census and sample. Census is the collection of data from every member of a population. So members of populations might be yes or no's or people's heights, and we collect every one of those. That's a census. So that would be ideal. If I wanted to know something, if I wanted to know how tall all the students at DVC are, the best thing would be for me to do a census and collect that information. But as we've said before, often if you have very large bits of information you want to collect, it's not practical to collect it all. But if you can, then that would be the most accurate results you could get. So for example, the United States conducts a census of important information once every 10 years. In fact, in 2020, they just finished one. So you probably at some point were asked to participate in the census, but it was literally an attempt for the country to collect certain kinds of information from every member of the country, everyone in the country, because the decisions that they're going to make based on that data is very important, or are very important. There's going to be lots of them. So they ask information about income. They ask information about where you live. Because, for example, they want to know exactly how many people live in California. Because based on that information, they're going to determine how many congressmen will represent California. The more people in a state, the more congressmen are sent to Congress on behalf of that state. California is very large. It has a very large population, so we have lots of people in Congress. Small states in terms of population have fewer people in the Congress. They will ask about money because decisions about taxes and all kinds of other things are made on how much money people make and things like that. What the average income is for everybody in the country. That's a very important number for lots of decisions. Do you make above average amount of income or do you make a below average amount of income? So a census is where you collect the data from an entire group and you create a population of that data that you have access to. But as we've been discussing, this is often not practical. And so a sample is a sub-collection of members selected from a population. So instead of having a census of the data from everybody, you have a sample selection of that data. So in my example of looking at the heights of 100 DVC students, I was taking a sample. I was collecting 100 height values instead of all thousands and thousands of height values, which would be the population. Questions, comments about census or a sample? All right, let's see if we can keep your minds engaged and help your minds learn these words. Try in your mind to imagine an example of a situation in which you would try and be able to collect a census. So this means thinking of a group that you're interested in and some aspect of that group that you want to observe, how tall they are, how much money they make, whether they've had COVID. But because of the group that you're thinking of not being enormous, or because you have the ability to collect data from an enormous group, you would try to do a census of that data. And if you're willing to share it, speak up or type it into chat. That would be great for the purpose of discussion. But give it a try either way. And then if you're willing to share it, please do. Okay, so I will give one example for those of you who are trying and not able to. If you did, but you don't want to share it, that's fine. But here's an example. I'm curious about which state's residents in a particular month want to go to Canada by car. Which state's residents are driving to Canada? Maybe it's because I'm concerned that people in Florida feel that they're too far away, so that they're going to take a plane and they're not going to drive. Maybe I'm curious whether only neighboring states to Canada are people willing to drive. Do Californians really willing to drive up to Canada much? I'm for some reason interested in people driving to Canada. Let's say Canada's interested in that information. So they could do a census of every person who drove into Canada, because they could just have all of the places where people cross the border and go through some sort of a checkpoint. They could have the people at the checkpoint collect the state that every person drove in from, either simply by, if they're waving them through, they could just look at the license plate as it crossed over, or if they're stopping and asking them the question, they could ask, which state are you coming from? And they could literally take a census of what state every person entering Canada by crossing the border by car came from. That's still pretty huge, even though maybe not so much nowadays with a 2-week quarantine in Canada. But nonetheless, that would be an endeavor. It would cost money. It would take time and effort, but they're in a position to do that because they already have all of those people in place, and they could simply ask them to collect that data. Okay, let's move on with that example stated. And we have a little less than 10 minutes left. So if you're thinking of some questions, definitely try to chime in the next 10 minutes. I will stay after class for those who want to have questions after class. That's fine too. So now that we have a few words under our belt, the example is given in the slides. Now, I've asked us to think of some examples. I've given a couple of examples, so I'm not going to spend much time on this. I'm just going to look at it very briefly. But if you later want to go and review the slides, you will see that the slides also have examples to illustrate the concepts that we're discussing. In this particular example, they talked about residential carbon monoxide detector failure rates in the United States. And apparently there are 38 million carbon monoxide detectors installed in the United States. And then they talk about randomly selecting 30 of them and testing them. So what things are going on here? They're talking about a statistical study that was being done. And you can imagine trying to use our new vocabulary in this context, which would be, what is the population? What would a census look like? What would the sample look like? Things like that, using the words that we've just discussed. So they, for example, point out that the population in this example would be all 38 million carbon monoxide detectors. What would the sample look like, the 30 that they took to test separately? The objective is to use the sample data as a basis for drawing a conclusion about the population of all carbon monoxide detectors, and the methods of statistics are helpful in drawing such conclusions. So then they have a little chart, which takes a little time to look at and think about, more than we have to do in class, but it's in the slides, it's in the textbook, and they basically try to give an overview of the idea of the application of statistics. How do you prepare to do statistics? How do you analyze your statistical results? And how do you draw conclusions? And we're basically spending the entire semester learning these things, so it's not expected that when you look at this flow chart that it all makes sense. It's expected that basically none of it makes sense. So I want to point that out so that you don't get anxious reading this and like, oh my God, I'm already not understanding things. But they do want to begin the semester with an overview so that as we are learning components of this process, and as we are learning how to do more and more, you're keeping the big picture in mind. You know, when you're learning how to use your turn signal and how to use your brake pedal in a car, the big picture is you want to know how to drive a car. So this is the big picture of like driving a car, and then slowly we will learn how to do each little piece in each part of this big picture. Questions or comments about this flowchart diagram before we move on?
I don't have a question on the flow chart, but like I just have like another question, like from an example that you mentioned earlier. So like when the first example you mentioned was like getting the heights from people from DVC, your population was every student enrolled in DVC, but your sample population would be those 100 people. But like you said that if like those 100 people, it might not represent directly the whole population of DVC. So like if you do a sample, would you have to like do extra work to represent those people correctly in that sample?
That's exactly right. It's a very good description of the process and how you look at the results from those 100 to then draw conclusions that you think are valid about the entire population since you didn't check all of them. That's what statistical analysis is all about.
Okay.
And so there's a lot of work in that. For example, we need to learn concepts like probability. We're not going to be able to say for sure exactly what the average height of all students at DVC are. We're going to make a claim like I'm 90% sure that the average height of the whole population is somewhere between 5'6" and 5'8". That would be an example of the kind of a conclusion we can draw. It's a statement about probability, perhaps with not an exact value predicted, but a range of values predicted that we feel fairly sure that the actual population's average is somewhere in that range. Does that make sense as the kind of a conclusion you could draw?
Yeah.
Okay. Great question. Everybody's brains are in the right place. So then they have another example, but this example focuses on the concept of preparation, which was one of the things in this flow chart. And again, I'm going to try to point to these examples and not go through them in detail as we don't have a lot of time left today. I really wanted to make sure people kind of understood what the slides do for you so that we can work with them to understand these concepts in class and how you can then go back to these slides when class is done to explore it more slowly in more detail. Or one of the other options I mentioned was how you might have these slides in front of you and scroll through those while you're watching somebody give a video lecture about the concept, because the video lectures will typically refer to these same examples in the slides. And that way it's kind of like what we're doing in class. And then you can replicate that for yourself when you're going over a section that we didn't have time to talk about in class, as an example. So we're not only learning about these introductory words today, but I'm trying to help students illustrate and visualize for themselves how you will take on the challenge of learning this material going forward as we go forward in the semester. So this was about boats, pleasure boats, and manatee fatalities from boat encounters. There was a question earlier about correlation. This example would be an example of trying to imagine if there's a correlation between how many pleasure boats are registered and how many manatee fatalities are reported. If they register a whole bunch more pleasure boats, does that lead to, or is there a correlation to expect a higher manatee fatality rate? So they discuss that, but they discuss it in order to not think that we could answer this question here, but to talk about the source of data, the sampling method. They're going into a little deeper the idea on the flowchart description of what it means to conduct a statistical study to investigate something. So let's finish with this one last example of a vocabulary, because this ends up being one of the key ones that they talk about a lot in your homework problems in the first section of the book. So one of the kinds of ways you could collect data from a sample is to have what's called a voluntary response sample. This is very, very common and used widely, and that's why it's a good concept to start with. A voluntary response sample, or self-selected sample, is one in which the respondents themselves decide whether to be included. So to piggyback on our discussion so far, if I was curious about how tall all the people at DVC were, the students at DVC, I could ask people, I could send out a questionnaire onto the internet or something and say, hey, if you're a student at DVC and you'd like to tell me how tall you are, please respond. And the difference was, instead of me picking 100 people, I let people pick for themselves whether they're going to tell me how tall they were. So immediately, that's just a method. Immediately you could ask yourself, is that a good thing? Is that a bad thing? How would that work? It's done all the time. So whether it's good or bad, it's done all the time. And then they have an example of a voluntary response that somebody might collect. And they give some examples: internet polls, mail-in polls, telephone call-in polls, things like that. So I'll give you one finishing comment about the example that I just made and how this concept comes into play. Do we think there's a possibility that if I ask people voluntarily to just decide to tell me how tall they are, that would cause my measurements that I get of how tall people are to be biased one way or another? Meaning, do I think maybe people would be more interested in telling me how tall they are if they're taller? If I thought that, then if I'm trying to understand how tall everyone is at DVC who's a student, and the answers I get are only from the taller students, then the average of my sample will be not very reflective of the average height of all the students at DVC, because all the people that decided to talk to me were taller than the average people. That would make the conclusions from my sample less valid or less reflective of the overall population if there was this self-selected bias involved. And this is an example of that. So that's what you'll learn in these studies, is that when you have a voluntary response sample, there's a higher risk that the data collect may not be accurate to the overall population, but that it may be biased or inaccurate in some way because of the fact that you let people themselves decide whether they want to participate or not. So that's where we finish class today.